Normally, teaching metals and non-metals, there are some things. But naturally, there are some things that either you use a book or you did not use a book as a teacher or as a student. You must always remember. So I want to teach you all those parts from group 1 to group 7. So we'll do everything. Then, all the parts that I feel maybe I might not remember myself and are important, then we are going to see them at the end of the day. But generally, when you want to study metals and non-metals, so please pay attention. We are going to solve questions after too. If you want to score very high in your chemistry, you cannot joke with metals and non-metals. You can't joke with that aspect. Majority of your questions, what we just did today, you will see them. There is no doubt about that. You will see them. But majority of your questions are metals and non-metals. But you will see a lot of chemical kinetics. Out of your 40 questions, you might see 15 of all of these ones. But the remaining ones, usually metals and non-metals, and some part of organic chemistry. So, when you are talking about metals and non-metals, except some parts that can be liquid. Example of liquid metal is what? Mercury. You can see that it's in general knowledge. They can jump you on the road and say, liquid metal is called what? Especially in these days of social media. So, it is a general knowledge that everybody needs to know. It is mercury. While your non-metals are usually gases and liquids, and one thing about non-metals is that you also have some non-metals that are solids, like your iodine, some part of carbon metals. I'm not talking about these things again. Metals. I'm not talking about these things again. But I'm just telling you, you need to know them. Existence of metals. How do they occur? So for these parts, I'll just quickly list some things you need to know. Most metals occur in their oxidized states. Those that are listening should be writing little that I'm saying, because all those little information is what you will get from your exam. Most metals occur in their oxidized states. They would have reacted with something and become oxidized. Most metals lose electrons, so loss of electron is oxidation. So whenever you see a metal reacting with another element, that metal is usually in the oxidized state. So if you want to get the metal back, so metal exists in an oxidized state. And that oxidized state of metal is usually called the ores. Now, how do you recover this metal? If it occurs in oxidized state, it is recovered by reduction. So I will list something for you quickly. In the ore, you have the metal. So they can ask you, your common metals and their ores, you need to remember. That means, how do they occur? Let's start with aluminium. They can ask you that what is the ore of aluminium? Bauxite. The ore is bauxite. Sometimes you need to know the formula too. Al2O3.water. They can ask you what is the ore of iron? The common ore of iron is hematite. I'm just telling you the common questions you can see. What is the ore of zinc? That is calcitride. What is the ore of lead? Galena. Which one is again? What is the ore of zinc? Zinc. So any of these metals, you can ask you of their ores. and you just need to tell them the name. Which other one is common? Most of the other ones like copper, I don't want to, these are the common ones they ask you. There's copper pyrite, there's magnesium, dolomite, calcium, and so on like that. There's sodium, which are the halides, Abby. So, but generally, these are the common ones they ask you in the exam. That what is the ore of aluminium, what is the ore of this, blah, blah, blah. Now, when you have your metals, most of these metals, starting from potassium, sodium, calcium, magnesium, so this is magnesium, aluminium, zinc, iron, SN2 plus, Pb2 plus, H plus, Cu2 plus, Hg plus, Ag plus, Ag3 plus. So for these metals, there are a lot of things you need to know about them. Carrying plus means they are oxidized already. If I have NaCl, in NaCl, I go from sodium plus chlorine to give me sodium chloride. This is 0, this is +1, that is oxidation. This is 0, this is -1, that is reduction. So anytime you see a metal in a compound, that metal has been oxidized. So if I write all this positive charge now, it means they are oxidized already. Now, as you go from top to bottom, their electropositivity increases. I'm just giving you general knowledge now that they can ask you. The electropositivity decreases. It means that the ones above are more electropositive. And you should know what that means. They can easily give electrons. The ones above can easily give electrons, while the ones below don't easily give electrons. That's what electropositivity means. The next thing you need to know is that most of these metals, they are obtained by reduction. From potassium to aluminium, they are obtained by what we call electrolytic reduction. So they can ask you which of the following metals can be or cannot be obtained by electrolytic reduction. Any one of these guys, we obtain it by electrolytic method. The rest, none of them is obtained. These ones are obtained by what we call chemical reduction. And not go up to all of them, let's say to lead, but to copper. But these ones are usually obtained by roasting. So if you want to separate them from their compound and you want to obtain them, that's what you go through. It's just a general thing. It takes a lot of stories, but for now, let's just get the point clear. So electrolytic reduction is a way of getting the metal from its compound. For example, if I have sodium chloride. If I want to produce sodium, I must carry out electrolysis. By electrolysis, I will get sodium. That's what I mean. We'll solve questions. Who has primates in organic chemistry here? So maybe we can use that to solve questions on each part as we are moving on. So that what I've said can stay in your brain. So if you have primates in organic. Then the next thing you need to know is that most of these guys let me put it inside this place. Sodium to calcium, they react with cold water. Any form of water they will react. Magnesium to zinc, they need hot water before they can react. Iron, iron must react with tin. So if you are talking about their reactivities, iron only reacts with tin when the iron is red hot to liberate hydrogen gas. But the rest of them, oxide, Fe2. The rest of them, when you react any of this magnesium with water, it will give you magnesium oxide plus H2. But when you react calcium with water, it will give you calcium hydroxide plus H2. All these are general knowledge. Now, continuing from here, are you following? From what we have here, they can tell you something about their nitrate decomposition. It's a common question. So, rubbing these parts now. When you take these metals and you heat their nitrates, the nitrates of this guy is this, KNO3. When you heat it, either sodium nitrate or potassium nitrate, you are going to get KNO2 plus O2. So heating of the nitrates of group 1 will give you nitrites and oxygen. So they can ask you, when you heat the nitrates, you get nitrites and oxygen. It's important. When you heat the nitrates of these guys, plus copper. Let's say I heat, which one should I take? Common one is lead nitrate. When you heat the nitrates of this guy, you will get oxide of the metal, you will get a brown gas, and you will get oxygen. Reddish brown gas and oxide of the metal. So that's the question they can ask you in jam. When you heat the nitrates of lead nitrate or any of these other metals, these are your products. When you heat the nitrates of these two, these are your products. I'm only summarizing important points. Now, when you heat the nitrates of these ones, these are your products. Common one is this, AgNO3. You will get the metal, the brown gas, plus oxygen. The rest. So you will get the metal, the reddish brown gas, so you might be lucky to see questions here in your exam. So they can ask you, which of the following metals? I think they asked the question there in mock. Which of the following metals can be extracted by electrolytic reduction? If you see any of these guys, yes. If you do not see them, any of these guys are like chemical. And what do I mean by that? You will carry out electrolysis here, but here you will use a reducing agent. So, don't worry. Now, these are the things you need to know about introduction to metals and non-metals. Know some general properties, all those common differences. So now that we know this, if you pick past question now, you will see questions on all these parts. So, the existence of metals, so you can read more about existence of metals. Just note these ones I've said, they are very important. The next thing you need to do is extraction of metals. Extraction of metals. So they can ask you to extract metals, and that's what I've said about electrolytic reduction and chemical reduction. That's extraction of metals or ores. Then concentration of the ores and concentration and purification of ores. Concentration of the ores and purification of the ores. One of the important things you need to know about concentration of the ore is the one that is called froth rotation. That is where they ask most of their questions. And magnetic separation. During concentration of ore, calcitrites or amicites. Because amicites are magnetic, calcitrites are non-magnetic. So we can separate them using this method. Anyone that is magnetic that you can think about, you can use that. Then, the next thing is we have what we call concentration of ore, which is what we call roasting and calcination. You use to sometimes listing all these things is just for you to have an idea of all the things you are supposed to know if you are in a normal class. These are the things that some would have taken time, like the whole day, to talk about. That's why I'm just listing them. But I'm only picking out the important points that you might see in the exam due to the short time. Those are the ones I'm picking out. And even if someone explains everything in class, most of these things too, you will still cram them. So, which means still try to cram the little I'm saying. When you start practicing questions, you get used to them. So, what we do in roasting and calcination is that calcination is you try to heat the ore in limited air. You heat the ore in limited air. But when you heat in ore, you heat the ore in abundant air. That means you supply enough air, then you call it roasting. So, for example, if I have silver sulfide, so to say, plus O2, then I roast this guy very well. Then I can produce mercury plus SO2. So most times roasting will lead you to the production of the metal. But calcination will not. This is an example of calcination. When you heat a compound in limited supply of air, you can see the oxygen is not here, then you will get CaO plus CO2. What you have just done is you have reduced that compound to a simple form. So you can now go ahead to remove the oxygen, then you produce your metal in a simple form. That is what we call calcination. So heating the compound in limited supply of air, that's how they used to ask in Japan. When you heat a compound in a limited supply of air, it is called what? Calcination. That's what I'm picking out the important one. There's no principle here. It's either you know it or you don't know it. All those ones we did before, they are principles. But these ones, there are some bit of principle with 90% cramming. Yes. So, that is all you need to know about the introduction to metals and non-metals. Everything. There are big past questions to solve. But now, we now start from, after you are through with that, we now start from group 1, group 2, group 3, group 4, group 5, 6, 7. You now be studying a compound and its an element and its compound. Elements and its compound. So we are going to start with group 1, group 2, group 3, transition elements, hydrogen and its compound, group 4, group 5, group 6, group 7. Those are the things we want to talk about now. so don't shake your head. I'm telling you all the things you need to know, then I will tell you what are important. So I'm not teaching you everything. It's not everything you need to know actually. But if you are red white, you should know everything. But if you know all these things I'm about to say, you are good. So can I rub the board? So this is the first thing you should talk about in your class. Normal. So let's now look at the things you need to know about group 1. Just the important part. Yes, stay sharp. Don't worry, we'll try to solve your past questions so that you see how to answer them. Anyone you can confirm, then you will now go and search for that. So, now, let's look at group 1. Can I rub these ones?
Yes, sir.
Yes. Oh, yeah, right. Please, nobody should see you. Wait the orange. Wait some people. Are you ready? That's just introduction. So let's look at group 1. For everything we will study, this is what you need to know generally. Every time you are studying metals and non-metals, you need to first know a lot of things about them, which we call the introduction. The introduction to the metals and non-metals. Like any group you want to study. Let's say I want to study group 1 now. I need to know all of the elements in group 1. I need to know some properties of those elements. I need to know their relationship. What makes them to be in group 1? Then after that, you need to know their physical properties. And that is usually done under periodicity. Then you need to know their chemical properties. The chemical properties can be common to all of them with some slight variation. Then preparation. How do we prepare them? How do you prepare those elements or compounds? Then you now take one of them. That one is usually the representative of the family and their compounds. In group 1 now, you first study everything. The elements in group 1, they are lithium, sodium, potassium, rubidium, cesium, and francium. Those are the elements in group 1. So you look at them. These elements in group 1, what are the things they all have in common? They have what we call the NS1 configuration. The atomic number for lithium is 3, Abby. Yes. This is 11. So if you check, this will be 1s1, Abby. 1s2, 2s1. By this one will be 1s2, 1s2, 2s2, 2p6, 3s1, Abby. Why this one? So you see NS1 is what will be a trend. This one will not be 4s1. In case you see what's the atomic number, you just write up to 4s1 and add everything together. This one will be what? 5s1. So you can see the atomic number of this guy. This one is 6s1. This one is 7s1. All these ones are just basics. I've not started. So now that you know all this introduction and basic things about them, then their physical properties. What happens to the ionization energy down this group? Ionization energy is going to decrease down the flow. And why it's decreased, you know that. The hydroxide, the solubility. Why are they called alkali metal? All those stories you need to know. Why do we call them alkali metals? Jambites. No problem. They are called alkali metals because their bases are water soluble. That is why we call them alkali metals. Their bases are water soluble. So there are a lot of things about that. Now, most of their carbonates are stable to heat. It's another thing you need to know. If I heat sodium carbonates, it will not decompose. All those are general knowledge. So to buy it any carbonate of group 1 aside lithium, it will not decompose. But if you remember, if you eat CaCO3, all of you already know the product. Because when you eat group 2, they will decompose. That's that. But now, you talk about all of those physical properties, you talk about their chemical properties like their reactivities. All of them now, they can react with water vigorously. They can react with non-metals, like maybe nitrogen, chlorine, and so on, sulfur. When sodium reacts with nitrogen to form sodium nitride, sodium with chlorine, sodium chloride, sodium with sulfur, sodium sulfide. All those are general knowledge. They can also react with hydrogen. It's normal. All of them will do that. But there are some reactions that are very important. Then you focus on sodium and its compound. So I'm just going to talk about this. This reaction, you have to take note. When sodium reacts with oxygen, it will give sodium oxide. Sodium oxide. When the oxygen is limited. So they can ask you, the reaction of sodium with limited oxygen will give what? Simple oxide. But when the oxygen is in excess, what will you get? Sodium peroxide. Is that correct? No. So this is sodium peroxide. That's one important reaction that you need to take note. So if sodium reacts with oxygen, limited oxygen, you form simple oxide. But if it reacts with excess oxygen, you form peroxide. You just pick your answer. Another important reaction you have to take note is this compound of sodium, sodium hydroxide. It can react with some metals like lead, zinc, aluminium, zinc to liberate hydrogen gas. It's a common question we can ask you. So when sodium hydroxide reacts with lead, it will give sodium PbOH Na2PbOH4 plus hydrogen gas. That's the most important thing. So when sodium hydroxide, which is a compound of sodium, I'm picking what are important, react with lead or any of these guys, so it can form sodium leadate or sodium stannate. Tin is stannate, or sodium aluminate, or sodium zincate. Then it will liberate hydrogen gas. It's an important reaction for group 1, which they can ask you when you start solving questions. Then, another important thing you need to know about group 1 is the exposure to air. But questions are not that common around that area. So, production of sodium, it's another thing. Extraction of sodium. So how do you get sodium? Sodium is produced in a cell called the down cell. So in case they ask you. So if you want to produce sodium, it is produced in down cell. and that is an electrolytic cell. In this down cell, what is used as the anode? What is used as the cathode? So you have graphite as the anode. Those are the questions you can ask during the production of sodium, and a steel as the cathode. Sometimes iron. Now, from what you have here, during the extraction, you extract sodium from what is called molten sodium chloride. Electrolysis of molten sodium chloride in calcium chloride. So another question. They can ask you here that there's a funnel that is used in this process. What is the use of that cylindrical funnel? So there's what is called cylindrical funnel that is used during the down process. The cylindrical funnel separates, because during this process they are going to produce chlorine. At which electrode you produce sodium? You produce chlorine at the anode, and you produce sodium at the cathode. So they cannot tell you that if you are produced from sodium chloride, you produce sodium and you produce chlorine. Why are you not using the funnel? The funnel is to separate the sodium from the chlorine, because if they come together again, they will react. So to separate sodium from chlorine, that's a question you can see. It's a question you can see in JAM. So the cylindrical funnel is used to separate sodium from chlorine. Those are the things you need to know about group 1. So even if you don't know everything I've said, try to know these ones. Know what I've written here. Let's move on to group 2 for metals. There's nothing much in group 2. They are basics. So there are a lot of things they ask you about this that you can answer. For group 2, all these metals aspects, that introduction was not be a question. So they can just ask you this: how do you produce calcium oxide? That is the question they commonly ask. From shells of snails or mollusks, as the case may be. When you eat the shells of snails or mollusks, you have calcium oxide and CO2. So that's the common question they ask from group 2. But before I move on to that, let me go back to this. There's what we call solving process, and they ask questions on solving process too. So when you are done with this, it's because I want to touch on the group 7. You need to understand something called solving. I might not talk about the plasma divisional cell, because you will talk about that about electrolysis and all. Now, solving process helps you to produce Na2CO3. These are the common questions they ask you here. These are the raw materials. Your product is Na2CO3. Then they will not say, what is your byproduct? So your byproduct of solving process is what? CaSO2, not that. Just try to solve questions when you are through. So you see some of these aspects and get used to them. It's not everything that we can spell out at this time, but the important things. So let me quickly give you the breakdown of the solving process before I move on. If you go and read everything, if you go and read everything, you see that most of those stories. So The first step to solve a process is that you will mix ammonia plus brine. Brine is sodium chloride in water. That's the first step, plus water. Then you will produce what we call ammonia carbide. Abi?
No, CO2. Ammonia.
The CaCO3 is heated to give CaO plus CO2. Abi? So you now take your ammonia carbide, NH4OH plus NaCl plus CO2. This will now give us NaHCO3 plus NH4Cl. That's the step. So now that you have NaHCO3 and Na4Cl, you want to produce this guy. So you will now take, we have used the CO2, we have this left. So you will now take that NaHCO3, you will now heat it. On heating, it will give you Na2CO3 plus water. So you have produced what you are looking for. So you have used our raw materials, Abi, to produce it. But you still have this left. So you will not take, you have this left and you have this left. You will not take CaO, you react it with ammonium chloride that is left. Then you will produce calcium chloride plus H2O plus NH3. So you can use this one again in the process. So you can use that again. That's the ammonia. And it is in the process. So that's A2CO. That's why we call it the byproduct. So these ones can be used again as the raw materials. So the question they can ask you here is number one. Solving process is a process used to produce what? Na2CO3. So produce Na2CO3, what are the raw materials? NaCl, ammonia, CaCO3. What is the byproduct of solving process? Do you get that?
Yeah.
Just get into that. Then let's move on to group 3. Metals. That introduction part, you know it very well. I taught the blank process then when we did post-UTME. That was when we did the blank process. So I used to teach it during post-UTME. No jam, they ask you the blank process. So I'll teach you during post-UTME. Then you said why did we not talk about the colors of the flame? Yes. What's the color of sodium? Golden yellow. Potassium is what? Just know those two. Those are the important ones. Sodium is golden yellow and potassium is what? Lilac. Can we move on? Can I rub the board? So for group 3, what are you expected to make group 3? Group 3 is aluminium and its compound. Abi? That's group 3. So you have to study aluminium. Let me tell you the questions they will ask you in group 3. These are the questions they are likely to ask you on group 1 and group 2. There's nothing much. But yeah, let's see group 3. Can I run the survey process now? We don't have time. We are going to group 7. Group 2, there's nothing much on group 2. Group 2 are usually basics. So if you know all those things about basics, like acid base and salts, you know basics. In group 2 you will see calcium hydroxide. In group 2, you will see magnesium hydroxide. So there's nothing they usually ask around here that you probably do not know. If I react a base with ammonium salt, I will produce ammonia. So there's nothing so special in group 2. That's why I'm skipping that part. Is that taking? But in group 3, they can ask you a question. Group 3 is representative of group 3 is aluminium. Aluminium and its compound. But you just need to know about aluminium majorly. First is introduction. Group 3, I gave them the word badges in my book. Badges. So, boron, aluminium, gallium, indium, and thallium. But you don't need to. We don't ask you what this was for now. This is jam. The only thing we ask you is aluminium. They can ask you questions on aluminium. When we have time, we can study everything. But there is no time. So, for them, they are usually S2, MD1 in configuration. That's by the way. So now for group 3, what do you need to know? The production of aluminium, extraction of aluminium. Aluminium is, what is the ore of aluminium again? Bauxite. So the common things you need to know is the extraction of aluminium. So what you need to know in number 3 is extraction of aluminium. These are things that must be ringing in your brain every time. You extract aluminium by a process called the Hall process. Extraction of aluminium is carried out by the electrolytic process of what? Of molten bauxites. Bauxites in molten cryolites. Abi? In molten cryolites. So, the first question they can, I didn't tell you the function of the CaCl2. We added to sodium, but it's the same function it performs as cryolites. So, the function of cryolites during the extraction of aluminium is to reduce the melting points. The melting points of bauxite. Is that taking? Please, just be following. We are not here to say stories. Just bring out points that you need. So that every day before your exam, you can go through those points. Those points you need. Now, when you add cryolites, when you will get aluminium from its biosite, but we add this guy. That guy, we add it, it serves as impurity. As impurity. So they can ask you, the question is, during the extraction of aluminium, molten cryolites is added for what reason? To reduce the melting points of bauxite. Is that it? Before this process starts, there is the purification process. And I'm just going to give you what you need. During the purification of bauxite, the chemical used is called sodium hydroxide. Align, how many is this body? Please, make all the bits. We are taking too much space. People are just 5. And why we better? So the next question they can ask you is that during the purification of biocides, what is the chemical used? The chemical is what? Sodium hydroxide. Is that taken? So, I don't need to talk about the electrolytic process. It's just general electrolysis. So, from the ore bauxites, you will produce aluminium by electrolytic reduction. Abi, I already listed all the metals that can be gotten by electrolytic reduction. So now, another thing you now need to know is not even about the properties or reactions of aluminium. There are no many reactions that they will ask you like that. But you should know that aluminium is not corrosive. You should know that. Now, this is another thing you need to now spend energy. This is an area where questions are commonly asked again on group 3. Uses of aluminium. They love questions on uses of aluminium. A lot of you have seen what they used to wrap all this cake before. Aluminium foil. Is that taken? So all of these things, the uses is where they ask you questions. So you need to know it is used in packaging of food. That's one. Packaging of food, they can ask you. Due to electrical conductivity, it is used in making electric wires. I hope you are getting that because it is highly conductive. All these uses. Aluminium is used in making your cooking utensils. They like asking questions on all of those things. And you remember, aluminium is used in making alloy. Abi, what is the example of the alloy? Duralumin. What are the composition of duralumin?
Magnesium, manganese, chromium and aluminium.
Is copper there? Copper is there. Is it not chromium?
No.
Don't worry, we'll get it. Magnesium, manganese, copper, and aluminium. These are the constituents of duralumin. Is that taken? There are other uses. Aluminium is also used in a process called the thermit process. If you have understanding of this, they asked question on that last year, but you don't need to know what thermit process is to answer that question. Oh, I think it's you that asked. The pots with the salt, you will talk about that later. So please, it is important to know the uses of aluminium. One thing you can do for me is that all these things I'm saying, after class or a day that you are free, you will just read all these parts alone. You don't need to go and read the whole stories. Just find a way to read all these parts. Or you have AI, ChatGPT, although it might not be useful, carry about you. Just go to aluminium and its compound. Read the aspect of uses of aluminium. Is that taken?
Yes, sir.
Don't carry TikTok and what's that one called? ChatGPT. You can go to, just open about you. All these things I'm saying, go to group 1. Look for those things I said. Try to study them. How they wrote them in the book. You don't have to read everything. Are you getting my point? Go to group 3. Look at preparation of aluminium. Study that part. Then jump to the uses of aluminium. Are you clear? Can we move on? Yes. Those are the things they can ask you on group 3. Let's move on to transition elements. Yes. So for transition elements, there are a lot of things you need to know about transition elements. And I'll quickly tell you the important parts and the parts we will need to check later. So let's start. The introduction to transition elements. The definition is they are elements with incomplete filled d orbitals. So the orbitals are not completely filled. So they can test you in this aspect and ask you that which of the following is a transition element, which of the following is not classified as a transition element. So let me just give you a list and we'll quickly see them. Scandium, titanium, vanadium, chromium, scuti, those are the transition elements. Scuti, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So, let's see the electronic configuration. I will write for scandium, then I will do something after. Scandium is 21, Abi. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Are you there? That is 21. And that represents the configuration of scandium. Show you. Now, what will be the configuration for titanium? It will be 3d2. Abi? But if you look at this, from year to year, that represents a completely filled orbital, which is argon. You remember argon is 18. So if you add all of this together, that would be 18. So I can simply put argon, 4s2, 3d2 for titanium. Everything from year to year represents argon. Then 4s2, 3d2. Do you understand that? So let's go for vanadium. What would it be? Argon, 4s2, 3d3. For chromium, argon, 4s2,
4s1, 3d4.
Please don't make mistake in the exam. When you get to chromium and copper, the configuration is 4s1, 3d5. If they write 4s2, 3d4, it's wrong, because a partially filled orbital is stable. 1, 2 from here to here. Is that the case?
Yes, sir.
So that's what you do. We will solve questions together. Just let your mind continue to follow. Anyone, I will know what to do to help you. So let's just finish everything first. Then we'll look at questions. Then I will sample some parts for you. So that's the configuration for chromium. What would that be the configuration for manganese? That would be argon, 4s2, 3d5. This will go back to normal now. Then this will be argon, 4s2, 3d6. Argon, 4s2, 3d7. Argon, 4s2, 3d8. Argon, 4s2, 3d10. So don't forget copper. This place should be filled. That's it. Argon, 4s2, 3d10. So that's the configuration. Now note something. This is the electronic configuration for transition elements. But what are the things you need to note? Let me quickly give you something very important. In this configuration, number 1, all these points are important as I'm saying them. One, which of them does not really fit as transition elements? What is the definition of transition elements? They are elements within completely filled d orbitals. So if you look at all this configuration, which of them does not really fit into the system? This is actually zinc. Because zinc has a completely filled orbital. So it's not that, it does not show the reactions others used to show. I hope you are following. I'm just trying to pinpoint all the parts we need for exam's sake. That's one. Zinc is an answer. Another thing you need to know, when transition elements, when they lose electron, they lose from their 4s first. Transition elements lose 4s electron first. If they want to undergo oxidation states, they have to lose electron. But what do they lose first is what we are looking at. Are you listening? So now let's look at it. If I have iron, Fe2 plus, what does this mean? It has lost 2 electrons, Sabi. Now, if I ask you that, where did you lose these 2 electrons from? It is from its 4s orbital. So 3d6 will remain where it is. Do you get that? Don't say it's lose it from 3d, it's lost it from 4s. So they always lose their 4s electron first before they start losing 3d. It's important to note that. Now, if I give you this, scandium plus, does this guy still fit as the transition element? Sc plus. Eh? How?
No.
It has lost its d electron. So this guy will no longer be there. Then it's no longer fitting the definition of what? A transition element. Do you get my point? Take note of that. When scandium loses electron, scandium, this is the configuration, Abi. So it will lose just that one electron. Yeah? No, for the normal configuration that you have, because it's just that one electron. So this one can be removed. So it is said to be non-transition elements in this state. But don't forget this part. Then, after you have noticed what I've said here, and don't forget the configuration for chromium and which element? Copper. They can ask you in the exam. Those are the points you need to first note about transition elements. Then, another question they can ask you. Don't let me. Their characteristics. They ask questions on that a lot. Transition elements, they have variable oxidation states. True or false? So they cannot ask you, why do you think they have variable oxidation states? It's not about they have variable oxidation states, it's about why. Why do they have variable oxidation states and others do not have? So all those reasons are what they now ask you in jam. The reason is that they have several electrons. So they can lose 4s, they can lose 3d. So they can lose different electrons in both the, you just say that due to their incompletely filled d orbital. That's why they show variable oxidation states. Because they form variable oxidation states, so they act as colored ions. Colored ions in solution. It's another thing you need to know about them. They are usually colored in solution. Yes. Because they have been completely filled d orbital. Everybody, if they now ask you that why do they have colored ions because they can form variable oxidation states. And those oxidation states are associated with their incompletely filled. So everything still falls back to incompletely filled d orbital. And what does that mean? What is the color of Fe2 plus? It is green, Abi, or dirty green. Color of Fe3 plus is what? Brown, Abi. Color of Mn2 plus is what? Colorless. Color of Mn7 plus is what? Pinky. This is purple. KMNO4. Purple. Is that not KMNO4? Then this is colorless. All these are things you should know normally. Cl3 plus is orange. Orange. Cr6 plus is green. No. This is green. This is orange. So this one is orange in the, don't worry, most times in your group it is colorless. But let's leave it here. But you remember this reaction that we will be testing for reducing agents. We go for KMNO4 to Mn2 plus. No, it can be pink or colorless depending on the condition. If it is basic or acidic condition. If it is acidic condition, it is colorless. That's what you used to test for. That's what you used to say that alkene will decolorize KMNO4 from purple to colorless. So it depends on the condition. So please, all those colors for now, they are not really that important. I'm just telling you that they can form what? Colored ions. Another thing they can form is that they form complex ions. Reasons for forming it. Why do they form variable oxidation states? Incompletely filled d orbital. And they have different colors because they can form variable oxidation states. How can you follow it? Now the next one is they form what we call complex salts or complex ions. And why do they form complex ions? It's another question. Can I rub on this color? Korean girl. So they form complex, all these are things you need to know about them. They form complex ions. And complex ions means that the reason they form this is because they have vacant orbitals. They have vacant orbitals. So other things can come and enter there. That's why. Then which other properties? They act as catalysts, stabbing. Because of this, they are very good oxidation states, so they can act as catalysts. So all these reasons are what they majorly ask you in JAM, not just the property. In WAEC, they can see properties, but in JAM, reasons, you need to have understood what happened. So now, in your exam, they will not help you to focus on iron. So you will now do iron and its properties. So let's quickly talk about iron and some part of copper, and we'll move on to the fourth. Iron and its properties. For iron and its properties, they can tell you how do you get iron. Extraction of iron. We usually call it smelting. Smelting of iron. Where does smelting of iron take place? It takes place in a place called the blast furnace. So it takes place in blast furnace. Blast furnace is that very hot container. So I'm just going to give you the equation of what happened in blast furnace because it's a common question too. Are you ready? So now, in blast furnace, you get iron from blast furnace under very high temperature. You can check the picture for blast furnace later. So what are the raw materials we need in blast furnace? Kí la need láti pèsè sílẹ̀ tàbí máa pèsè irin iron. What's Yoruba for iron? So the raw materials are the iron ore. Iron ore is what? Amicites. We will need amicites. We need CaCO3. We need coke. We need coke. So now, from what you have here, we can produce iron. Can we start? Yes. So the first step is that you eat CaCO3. When you eat CaCO3, you get CaO plus CO2. Are you there? Another thing is this coke. That's actually the first step. This coke will react with oxygen to give CO2. That's step 1. Step 2, CO2 will react with more coke to give us CO. Are you there? Now, the CO will react with amicites. Fe2O3 to give us Fe plus CO2. Then we have produced our iron. But during this extraction, there's usually an impurity present. Those impurities can be aluminium oxide or silicon oxide. So those impurities present are usually earthly impurities. The one from clay, the one from sand, and all. Maybe because of the metal. So those impurities are silicon oxide, aluminium oxide. Are you there? So now, you have produced your iron, but you need to remove these impurities. How do you remove the impurity? You use CaO. That's why you are using this guy. So they can ask you, and we ask you general questions when I'm through now. So the CaO will react with the earthly impurity to form what we call slag. CaSiO3. This is called slag, or the earthly impurity, or calcium trioxosilicate 4. That's the impurity that has been removed. Are you following? So now, step 1, check. Step 2, check. Step 3, check it. Then step 4 is to remove impurity. So now you can see we have coke. That coke reacts with air in the furnace and it produces CO2. The CO2 will react with more coke to produce CO. Then the CO will now react with the amicite to produce iron. And this process is a chemical reduction. Can you check the CO here? What is he acting as? Is he as a reducing agent or as an oxidizing agent? He's acting as a reducing agent. This one will undergo reduction. You have removed oxygen. We can do, I thought, oxidation and reduction. So, that's by the way. They can now ask you, what is the function of CaCO3 in this process? The function is to remove impurity. So this is the acidic impurity. Acidic impurity. Why this one is the base? So you remove impurity, which can either be this or this. You remove it as slag. So that is iron furnace. No, now we have types of fire. I'll just list them. But I'll need you to note something from the types of fire. Are you there?
Yeah.
Can I run the board? These are things you need to know. These are questions you can ask me. And you are lucky that you are learning all the important points today. That we did not see it like you have time. And you still have like 12 to 13 days left. Or 10 days left. So you can go home to go and practice all these things again. I've always been telling you, you can read in 10 days and do better than someone that will read it in 10 months. It depends on your brain, mentality, and how you push yourself. So please, let's work on it. So to all of you that have been paying, that have joined the foundation, God bless you. God will continue to enrich your pockets. When we want to do conference, I pray that you will not be missing. You will also be celebrated. So it's just to help the less opportunity. So if you have anybody that will need help, don't tell them now. Before they start, some people have been calling me already. That I don't have money for school. Then my friend said I should call you. Please, don't tell them now. When it's time for starting next jam class, that's around August or so, then we'll roll out flyers. We'll do flyer to say that if you know you have issues, you can apply. Then you can now start recommending people. Then when they come with our dollar screening for, we do screening for them. Then we'll get those that want to pay and we sponsor them. Is that taking? So don't start telling them what to pay you. So now we have types of iron. So after you have produced iron, then you have some types based on how pure it is. The one that you obtain directly from the blast furnace, immediately by that you produce. The one we produce from the furnace directly, we call it pig iron. And you already know what that means, elected. Pig iron is the one that contains the highest amount of impurity. It is not pure. Is that taken? And then you well done. It is very, very impure. Then you can now add more iron, metal, scrap. Please read these parts from your Bible. Know how we remove the impurity for each of them. They ask you. If you have primers, that is you can practice. So this one has the highest form of impurity. The next one is cast iron. When you have removed some impurity from pig iron, then you now have cast iron. The one you use in making all your stoves. Nail. Have you seen stove before? Yes. There's nobody that is going to UI that will tell you I've never seen stove before. As a student of UI. Stove. Everybody in UI, they use stove. If you are talking to UI, go and buy stove. If I stay private stove, you will now be buying kerosene. Buy kerosene. Show me the stove. That's a vacation for Ghana. I have not stayed in this school. So I have not been school. I used to be there. I made some. In our máa gbé kẹ́kẹ́ lọ́mọ wá kéré sí láì ṣe ṣe. So can we move on? So if you have seen smoke before, Emma of this smoke will not take the rust. It's because iron don't shade to pure data. So now iron is usually cast iron. Is that taking? But there are some iron that are very, very strong. They use them in making bridges and all. They have removed all the impurity from those ones. They just then those ones are called. So they can ask you that the purest form of iron is what? Wrought iron. But please, for those that have read very well, go and know how to remove all those impurities. It's in about you. How do you get rid of those impurities? Some of them, they will add some scrap of the metals. They will add it to it. While some of them, they will just use carbon or coke to remove it. They usually use coke when they want to produce wrought iron, so that they oxidize all the sulfur, they blow oxygen through it. So please, aside knowing that this one is pure, this one is impure, try to know their uses. These are the things you should do for me. Which one is the one that contains highest amount of impurity? Which one is the most pure? So what you are going to do for me is that know the uses of each of them, because they still have their uses. Big iron has its use, cast iron has its use, wrought iron also has its use. Is that clear? Then number 2, try to know how to remove impurity. How do you remove the impurity? Try to know that. It's important. So let's move on. Now, the next thing you need to know is majorly test for iron. How do you test for iron? Iron has 2 oxidation states, Fe2 plus and Fe3 plus. So they can ask you, how do you test for iron? Please read about that. It's in your Bible. You will see a table. The table shows test for Fe3 plus, test for Fe2 plus. The one that we give you, if they say that you have a blood red color, blood red, blood red, then that is Fe3 plus. And the formula is like FSCN, FSCN. So just go and check on this part. It's in the book. They can give a bluish color. Know the formula of the one. Is in that, I already did it in that video I did on YouTube. I'll show that part. But I'm just saying it again. So, if you can't read about you, go and watch the video. So you already get. So those are the things you need to make an iron. Then the next thing you need to know are the uses of iron. God have mercy. Mercy! Good.
Kí ló máa ń ṣe òkú ẹ̀? Miriam, kí ló máa ń ṣe òkú ẹ̀? Màtọ́ máa sọ sí ẹ̀ ní ìṣòro pariwo. Máa tètè ẹni lẹ́yìn ìgbà ẹ̀ máa sọ ìlò.
So, can we go on? Please know the uses of iron. Know the uses of iron. Then for copper, copper is another transition element that we spend energy on. But let me tell you the things to know about copper. Are you ready?
Yes, sir.
Please, go and know the uses of copper in making coins. You use copper in making medals, in coin. Just go to Ababio assignment, read that part of uses of copper in making coinage, coin. They ask you, read that one. I'm telling you the ones you can read on your own. The ones you might not be able to read on your own are the ones I'm teaching. But as I'm telling you, shall be noting them. They will ask you. They will ask your friend. They will always ask for. So you don't know if you are the one.
They said it is not.
You are still on metals. So please note the uses of copper. Then there's one important reaction for copper. When I get, let me say it now. Let me say it. Are you there? So you take copper. Ah. You react copper with HNO3. Please note this reaction. They might ask you, they might ask your friend, they might ask your friends. Copper is also a transition metal, and there are a lot of stories about copper too. But where they usually ask questions on copper is this aspect and the uses of copper. Is that taken? You know, copper is forming bronze and it's forming brass, all those things. Copper is also forming duralumin. So all those uses, go and note them, and the alloys, they are common things. Oh yeah, so note something here. If they told you that this guy is cold and dilutes, then you should note your products. Cold dilutes HNO3 with copper will give you NO. So you're going to have CuNO3 plus H2O plus NO. I'm not balancing the equation. If your question says that the reaction of copper with cold dilutes HNO3, what will you get as your product? That is NO. What is the full name for this guy? I said it in that video. I should be careful. That people used to make that mistake. Because of one oxygen, they used to say nitrogen 1 oxide. No. This is nitrogen 2 oxide. If you are confused, calculate the oxidation state. There's nothing you cannot do in this world. See pressure back in. Organic everything. Normally there's time going to I might have been saying some stories that is not necessary. I might have been encouraging you, but who encourage myself? For now, encourage yourself. The next one, the one that we have encouraged you is enough. If by now you are not motivated yourself, nothing can motivate you. Exam one of them, they were motivated. So, when it is hot, concentrated, then you get another product. So the products are CuNO3 plus A2 plus NO2. Every time you hear brown gas, not brown wrinkle, I explained it in that video too. Brown gas is NO2, not brown wrinkle. I'll get it. Are you there? So when you hear that you are using not HNO3, your product will be NO2. When you are using cold dilute HNO3, your product will be nitrogen oxide. Exactly. Note that statement. That's what you need to note. Then please read about uses of copper. Uses of copper, not just in making alloys. But another thing is, if you get to that uses, I just cannot remember vividly. If you get to that uses, you see that they will give you the constituents of coinage. And they need to ask you all these things. But you will not see it under normal alloy. You will see it under the uses of copper. And they will ask in the exam, and you will not be like, when did they see this one? Oh, Kawil. Robata will. Let me see. Is that uses of copper? Maybe they did not write it. As you move on, you see, for chronic care. Can we move on? So these are the things you need to know about the transition elements. Then you can evaluate. So let's talk about group 4. Before I talk about group 4, let's talk about hydrogen. Hydrogen and its compound. Hydrogen and its compound. Quickly. We are still moving on to group 4. Then group 5, group 6, and group 7. Don't worry. For group 4, I mean for hydrogen, you need to know the introduction to hydrogen, the physical properties of hydrogen. Why is it found in group 1? Why is it a non-metal? All those stories you need to know. Then you also need to know what do you call them? Isotopes of hydrogen. What are the 3 isotopes of hydrogen? As I'm missing them, in case you don't know, note them. Protium, deuterium, and tritium. Deuterium is the one that forms what we call heavy water. Is that taken? Don't forget all the assignments I'm giving you. Then note the one that have neutron, all those ones you can calculate it even if they ask you. So, when you leave that part, some of you are talking too much. If you already know it, it's okay. There are people that want to learn. Because we are coaching for 6 years in secondary school. That's a lot of fun. So listen. The next thing you need to know is that preparation of hydrogen. Preparation. They can ask you in jam a common question. The process of producing hydrogen from water gas, it is called Bosch process. So let's learn Bosch process. That's important to my class. So, are you ready? If you are a primary student, make sure after your exam you send me your results. Make sure you send me your results. And make sure you let me know the questions you solve. So that we know how to get better. In case most of these things we are saying, you saw them. So keep your mind to it. Is that thinking? For real, you have been taught. There's nothing at this level. If we can take our time like this to finish chemistry, and you do your own part of the assignments, and we do for physics, we do for biology and maths, there's nothing that says you can't stop working your own. Sincerely, if you do your part, very good. Don't look at it like 10 days, like steps. If someone should tell me that, please come and teach me in private class, I will pay you this, I can't teach the person. I will not give that time. Because I don't really have the time. So all these things are doing for you, it's a whole lot of sacrifice. So, and I know how much. Did you know that some of these people watching on YouTube, I did not know, they just said that to send an account number, that they want to pay for the class. So, one of them even said, he does not really have much, but he will first send 3,000. So before the end of the class, he will send him maybe 2,000. So after he sends the money, and I say, okay, we'll see class tomorrow. As I said, no, I'll be watching on YouTube. You watch on YouTube, why are you not paying for class? You don't need to pay for class now, it's free of YouTube. So just watch it. So people people, parents have been calling, how much are they going to pay? Nobody is paying for YouTube. Just watch. It's always done. All these things now will remain on YouTube. So you can watch anytime. You don't have to pay for it. So the youth. Can we go on? So the whole man will have that up. Can we go on, please?
They said this place is noisy.
This place is
Noisy. They said
the people at home, they already said you people are noisy. What them marry?
last night, yeah, they said this place is noisy. Only like this place is noisy.
You cannot. It's not easy.
The noise is too much. Like,
The noise
this
is
place
too much.
yeah.
It's noisy. Some people are watching with their parents at home.
They said tell them so young. They said tell them to please. Only can reduce noise in there.
So it's okay. God will bless you too much. Physical class is always better than online. But we can utilize what we have. Now they cannot hear because we don't have mic. So they're only hearing your noise. So it's okay now. Let's go, please. Let's continue. Time is going. I'll send you out to. Please, let's keep quiet. It's okay. It's okay. We still have the long way. So, please, let's keep quiet. What's the paying online already? That when we come, don't let me come and be begging, please, please, please. So that we don't waste energy. So that one. It's okay. Once I say three of you go outside in the sun, that's when you will know I'm serious. It's okay, it's okay. And there's rich people going, you know. Walk on my bed. And then you sit like the man. Oh, look, that's it. Oh yeah, let's go back to hydrogen and its compound. So I said we are looking at the preparation of hydrogen. Don't forget deuterium, protium, and tritium. They can ask you questions on those ones. And deuterium is called heavy water. I mean heavy hydrogen that forms heavy water. So during the preparation, which is the most important one, hydrogen is produced from what we call the Bosch process. So when you produce hydrogen from water gas, then you have the Bosch process. How do you produce it? You will take coke, then you heat it in steam, then you will produce CO plus H2. CO plus H2 is called water gas. That is called water gas. So anytime they ask you, and it is combustible. CO and H2 will burn in oxygen. Now, the CO will further react with more steam to produce CO2 and more hydrogen gas. Can you see that? So, the water gas will react with, this is steam, this is coke. So when you produce hydrogen from water gas, this is water gas. Then you react it with more steam. When you react it with more steam, you liberate hydrogen gas. Then that is one of the preparatory process. Then This is number one. They can ask you, how do you remove CO2? According to Ababio, in order to remove CO2, you will wash the products under high pressure. So you wash in water at 30 atmosphere, high pressure. So when you wash it in water under pressure, you remove the CO2. Is that taken? Then the next thing is that the remaining CO, that's probably the CO that didn't react. You remove that. What do you use to remove CO? You remove it using ammonia, solution of copper 1 ethanate. So that's how you remove the CO. Is that taken? So you remove the CO2 under pressure by washing the water, then you remove this using ammoniacal solution. Are you there? Please note all these points. When you start solving questions, apply them. I'm going to ask you questions when I'm through. So, the second process of producing it is no longer wash process now. It is from synthesis gas. You produce synthesis gas when you react methane with steam. Then you produce CO plus 3H2. So the difference between this and this is that this is 1:1. She gets, but here it is 1:3. So this one is called or synthesis gas. Is that taken? So, since you know about water gas, you know about synthesis gas, I think I need to just quickly introduce you to producer gas. That is not under hydrogen, but just to tell you about it. So, we can also produce hydrogen through that process. Now, another thing you need to know is producer gas. Please. Producer gas is when you take, is it Coke? Coke plus air. Nitrogen is present in here, oxygen is present in here. Then you produce CO plus N2. This is called producer gas. Is that taken? So this is called producer gas. Are you there? So note the difference. Producer gas is CO and nitrogen. Sorry, this is syngas and this is water gas. So they can ask you. They can ask you, how do you produce water gas? From coke and steam. How do you produce syngas? From methane and steam. How do you produce producer gas? From coke and air. Are you there? Yes. Then they can tell you that why is it that this one does not give more heat or energy compared to this and this? Because nitrogen does not really support combustion. That's why. So presence of nitrogen here reduces its combustibility. Are you there? So when you know this, there are still other stories for hydrogen. The next thing you need to know for hydrogen is the test for hydrogen. When you hear that a gas gives a pop sound, anytime they describe it that a gas gives a pop sound when introduced into a lighted sprint, then that's a hydrogen. Hydrogen supports combustion, but it burns in oxygen, but it does not burn for long. It will quench the fire. So, test for hydrogen. So how do you test for hydrogen? It's a common question you can see. So when you hear that a gas introduced to lighted splint gives a pulse sound, then that is hydrogen. The moment you hear that word pulse sound, that's then you have hydrogen gas. Do that work. Are you ready? Can I rub the board now? So, another important thing you need to know about hydrogen is uses of hydrogen. Is that taken? Hydrogen is used in filling balloon, but we no longer use it. We use, which gas do we use? Helium. Why do we use helium? So we use helium in filling balloon because it is light and non-combustible. It does not support combustion. Is that taken? That's why we use helium now instead of hydrogen. The most important use of hydrogen is in fuel. The second most important is in production of ammonia. Is that taken? So hydrogen is used as fuel, and hydrogen is used as in the neighbor process to produce ammonia. Which other use? There are lots. Hydrogen is used in hydrogenation, but the ones that are important are mentioned there. So note one of those uses of hydrogen. Can we move on now to the next thing? So let's talk about group 4 quickly. There's nothing much on group 4. But flames. Please, on group 4, we need to know about flames. All the zones. Candle flame. How many zones do we have for candle flame? How many zones for hydrogen? So, which other one? One single, how many zones? What's the difference between luminous and non-luminous? How many places? How many zones do you have for? In luminous, the air is closed. It is open in non-luminous. So you'll be seeing the particles of carbon. So to show the luminosity. Wait. Which one is luminous? You said the air is closed. When you close the air, you don't get oxygen supply. And you start having complete combustion. Yes, that's correct. So, for luminous, the air will be closed. For non-luminous, the air will be open. And you have extra zone in the luminous. You have 4 zones in the luminous. How many zones for non-luminous? I think it's 3 zones. You have 3 zones. You have the blue zone, all of those things. So, the most important thing to talk about group 4, quickly. Let's talk about group 4. Those are the calcium, carbon, silicon, germanium, lead, zinc, and so on. Abi? Can we talk about group 4? Please, up till now, have you gotten something? All these things I'm talking about, they are just the important parts. So if you go and read the whole, even if you are reading it on yourself, these are the things you should be taking notes. But I've brought everything out for you. So let's go on. Check for your charge. So you're keeping it recharging, not yeah, look at it then. What is it? So please, let's go on. Let's keep quiet, please. We're already spending too much energy. Our time is going. We are spending too much energy. We have not finished group 4, group 5, group 6, group 7. So please, let's keep quiet. I'm only allowing you to talk so that you don't get tired, especially when it comes to metals and non-metals, because it can be boring. But I'm allowing you to talk so that I can give some of these things in your brain. But you are misusing the opportunity. You are talking too much. You don't know when to keep quiet. So please, let's keep quiet. What I want you to know about group 4 is majorly, we are talking about carbon. So first know the allotropes of carbon. That's number 1. What are the allotropes of carbon? We have 2 types. We have the crystalline and the amorphous. The crystalline are the diamond, graphite, and pop crystal fullerene. Is that okay? Diamond, graphite, and pop crystal fullerene. Then the amorphous, they are the coal, charcoal, and so on. Is that taking? What's the difference between crystalline and amorphous? Crystalline have shape, they are crystals. But amorphous are powdered form. Now, when they ask you which of the allotropes is used in pencil, lead pen. Is that taking? Then another thing you now need to note. What are the difference between graphite and diamond? Don't let us give Coron's answer. If you know the answer, raise hand up, then you write it. I don't want us to waste time. Graphite. What is the shape of graphite? Hexagonal. What is the shape of diamond? Yes, note it like that. Is that taking? Note it. Which of them conducts electricity? Okay. You know why it conducts electricity? Yes. Due to free mobile electrons. Now that you understand the difference between diamond and graphite, the next thing is, how do you produce diamond? It's the next question. How do you produce graphite? The Atkinson process. By heating. So please, let us check for preparation of graphite. How you produce it. Now, another thing is we now have destructive distillation of coal. Abby, what is the destructive distillation of coal? So when you eat coal, it's going to give you 4 products. Abby, that is coke. Coke is the solid plus quota. Quota is also a solid, Abby. Plus liquid. Gas. So those are the products. The solid. So they ask you that the solid residue from the destructive distillation of coal is what? Coke. That's the solid that is deposited. Coal tar too is solid. Ammoniacal liquor is the liquid. This is the gas. Is that taken? Now, you need to know their uses, but most times they don't ask you. But you have charcoal. What are the types of charcoal we have? For sugar charcoal, how do you produce it? You take sugar. So they can ask you this. You heat it under H2SO4. Then you produce carbon and water. So when total dehydration of sugar, like total removal of water, then you produce this carbon. This carbon is what we call charcoal. And that's because it's produced from sugar, so it is called sugar charcoal. Is that taken? Yes. So they use H2SO4 to remove the entire water. So it's acting as a dehydrating agent here. Is that taken? Yes. So that's sugar charcoal. Animal charcoal. When you burn the bones of animal, okay? So you get animal charcoal during the burning of bones of animals. Then you have animal charcoal. Now, you have wood charcoal when you burn wood, burning of wood. But now, let's note something. What are their uses? Is a common thing you need to take notes of. Oshio, I need your computer. The house. And you will not throw your husband home. The women, don't forget, it gives refreshing taste, Abby, when you have it in soft drinks, Abby. So CO2 is used in salt drinks. And don't forget, CO, you don't allow it to, if you are burning carbon in oxygen and the air supply is limited, then you will produce CO, Abby, bind, and it can lead to brain damage or anything, or suffocation. When you want to produce CO, please, oil is used as dehydrating agents. Note that. Dehydrating agents. Note that. During the production of CO, using ethane agents, they can ask you that exam. During the production of CO, using ethane dioate or ethane dioic acid. Ethane dioic acid. I should still have it. Okay, no need to get. Using ethane dioic acid. What is used as dehydrating agent? So please, that H2SO4, be careful with that guy. Sometimes it's used as catalyst. Sometimes it's used as oxidizing agent. Sometimes it's used as dehydrating agent. So you must know where it is used in specific. Please, do you understand that? It's a very useful guy. Let's move on. So, just use it, and I don't think there's anything much about CO2 and the lights again. Every other thing, there are things you can think about. So the next thing, we should move on to group 5. Group 5 are nitrogen compounds, Abby. So our focus there is just nitrogen. look at nitrogen and its compound. I'll just quickly tell you some important things about nitrogen and its compound that you need to always know. So, are you there? Yeah. You have nitrogen, you have, is it phosphorus in that group? Astatine and NEPA, baby. So, I will need to look at that. We have not talked about sulfur. So are you? It's okay, it's okay. So nitrogen and its compound. First is nitrogen. One of the things you need to take notes about it. You have studied air now. I think you people have done air. And you have done some things about liquefaction of air. So nitrogen preparation. There is a common thing that you need to know about those guys. You will see N2, NO, N2O, NO2. So now, number one thing you need to know is the preparation of nitrogen. These statements during preparation. When you eat ammonium dioxonitrates, you will get nitrogen. Eating ammonium dioxonitrates gives you nitrogen plus water. That is an important reaction you need to take note. But you remember that this reaction is not carried out directly. You will first react sodium nitrate with sodium chloride or something before you produce this. But anytime you hear that you are decomposing ammonium di, this is ammonium dioxonitrates 3. So eating ammonium dioxonitrate 3 will give you what? Nitrogen gas. In comparison, if you eat ammonium trioxonitrate 5, then you will get N2O instead of. Now, N2O is the one that you call nitrogen 1 oxide. Don't make that mistake. Nitrogen 1 oxide. Don't because 2 is here and say it's nitrogen 2 oxide. Is that taken? This one is nitrogen 2 oxide. This is nitrogen 1 oxide. This is nitrogen 4 oxide. So this compound is called ammonium trioxonitrate 5. Show you. So when you eat ammonium trioxonitrate 5, you get these products. They can ask you in the exam. Now, what do you know about this guy? It's a common thing. What do you know about N2O? So go there. So it is usually called laughing gas. Used in anesthetics, during anesthesia. So they used to give it to patients, and the patients will wake up feeling so excited and just be laughing. It's not that laughing, no. It's just like you just be happy. So we call it laughing gas. You cannot compare laughing gas with oxygen. It's a common thing they test in your exam. Both of them. Both support combustion by rekindling a glowing splint. Is that taken? So both nitrogen 4 oxide and nitrogen 1 oxide and oxygen, they rekindle a glowing splint. But what's the difference? This one has a sweet smell. This one does not have a sweet smell. Odorless, tasteless, colorless. Is that taken? Another thing you need to note about this guy is that N2O does not react with NO. So N2O plus NO. But this one reacts with NO to give NO2, which is a brown gas. All these are the important things you need to know. But anytime they wake you up and they ask you, you should be able to tell on metals and non-metals. There are a lot of stories. Yes. But these are common stories that you should always embrace. Are you following? Yes. So, what else? I've actually talked about that copper plus HNO3 before, Abby. So there's no need to repeat that. When you react copper with HNO3, you can either produce NO or NO2. Abby, I've talked about that, it's in your notes already. So I don't need to repeat that. What else? Okay. What we have, copper plus N2 will give us what? Eh? But there will be no residual gas here. Copper plus O2 will give what? CO. Adding. So, any other thing to note on nitrogen and its compound? There is nothing you don't know about ammonia, Abby. Ammonia is gotten by Weber process, Abby. And the catalyst we use during Weber process is what? Finely divided iron. So we don't need to repeat that. Another thing is what we call the Ostwald process. Ostwald process is used to produce what? HNO3. We use it to produce HNO3. What's the name you call HNO3? Aqua Fortis. But what is the one you ask in the exam? Aquarega. HNO3 is called Aqua Fortis. But when you mix HCl and HNO3, that is called Aquarega. In what ratio? 3:1. Which one is 3? HCl. So you have HCl and HNO3. The ratio is in HCl is 3 in volume to 1 HNO3. So this is called Aquarega. Is that taken? Yes, sir. So we use nitrogen in producing HNO3 by a process called the Ostwald process. So those are just the things you need to know. There's not too much about it. Then there are a lot of salts. Let's now look at brown ring tests. Because it is around here we know about brown ring tests. Can I rub the top? Yes. So note this. Brown ring test. Brown ring test is a test used to test for compound that contains NO3 minus, probably like HNO3, NaNO3. So if you want to test for NO3 minus, you carry out what we call the brown ring test. Please note that. Brown ring test is used to test for what? NO3 minus. You don't know how much of information you're about to do. It is until you get home or you probably start solving questions. So now, this guy that you have here, the reagents you use during brown ring tests are Fe2 and the FeSO4 and A2SO4. So you take a test tube and you pour A2SO4. You put the salts inside the test tube. Then you pour FeSO4. Then you now start pouring A2SO4. Then at the end of the day, you are going to have a separation. You are going to have something that looks like a ring around here. While some liquid will be below, while some will be above. So what we separate the two layers is the brown ring. And that brown ring, the formula is FeSO4.NO. That's what will be at that area. So, in some cases, you can just say whatever the salt is, NO3 minus plus FeSO4 plus A2SO4 to give these major products. It's not just a simple step like this. So this is the brown ring. Just in summary, it's not always like this. In JAM, they did something like this last year. They just put X here. And they said that what does that X represent? So that is FeSO4 dots. They have all these different equations. And that's that. So that's what we call the brown ring test. It is a test used for what? To test for nitrate salts. Nitrate salts, NO3 minus. So I think those are the most important things about nitrogen. If I remember any other one, I'm gonna let you know. I'm gonna let you know. Whether you know the song, you can't just sing along. I'm gonna let you know. I'm sure you don't know. You really do not know. And I know you don't. But if you sing along, I'm gonna let you know. I'm not sure we can blow, even if we enter studio. When they put bomb in our mouths, we might eventually blow. Chorus. One thing I'm sure is that if they put bomb in some of your mouth, you still cannot blow. Coffee bombs and leg will be blow. So, can we continue? So, the next one to look at, we are through with group 5. Let's look at group 6. Group 6. Okay, group 7. Group 6. Group 6, that's sulfur and oxygen. Yeah. Sulfur and oxygen. One of the important things you need to know about sulfur is the preparation. That's one. The allotropes. That's two. During the preparation, you carry out what we call the fresh process. Please know about the fresh process. Preparation of sulfur, fresh process. I hope you are listening. Then you need to know about the allotropes of sulfur. What are the allotropes of sulfur? Rhobic sulfur, monoclinic sulfur, amorphous phosphor. Abi? Don't worry. Move on. It's a moment you move on in life. Well, lady go to him as well. Don't worry, I've learned all of those things in debates. When you are debating and you make mistakes, you don't wait, you continue. And it was known that Primus is the best university in Nigeria. As you are saying it, everybody say, hey, you just move on, bother. But if you not say, is it not mistake? Did I not just make mistake? Well, yes, I remember. That's why I never forgot the debates we had in OAU with some loud tech guys when I was in 200 or 300. So we had a debate and the loud tech guy. Sir, please make the class interesting tomorrow so we won't sleep off. Okay, they water bed, wow. You can drink water bed. Okay, they water bed. So, comedy, let's move on. I actually want us to talk about that. Is there any place you are really going on Monday? The thing is that on Friday, Jesus died for us. All of you were still chopping, you were still eating chicken. And you were eating Jesus. Instead of you to be crying, you are still chopping, you are still eating chicken. I understand the joy that comes with the death of Christ. I understand. But Monday, sincerely, so that we will not stress overnight. And some of your parents are already saying that we need security in town, this and that. One for God, your man, one love. Should we just make it some money?
Garlic.
Yes, yes. It is important to make Jesus. We met Jesus in Galilee last year. We will meet Jesus in Galilee this year. So Jesus, the only time you will meet Jesus is in Galilee, once in a year. You're a Christian. If you are going to Galilee, leave the Galilee thing. It's okay. So, if you, nobody should talk again now, please, so that I can end my class. If you want it to be tomorrow evening, you will raise up your hand. Tomorrow evening, overnight. Sunday/Monday. Your answer, your answer. You want it to be tomorrow evening and you know your parents will not call me. Your answer. So hands down. You want it to be on Monday. Hands up. You see, that's why Nigeria is not moving forward. Yes. Instead of you to stand your ground because others are not voting, Osalika was there. It's okay. I mean, please, it's okay. Let's continue. If it is going to still be tomorrow evening, I will send it on the group. So, and the day shall to do before tomorrow. Is that okay? So, please, I said number one.
Yeah. Yes, now.
Spend it to Tuesday because you can't cover organic chemistry 1 hour. That is of everything. You cover organic chemistry 1 hour. I'm going to church by 7 p.m. You want to make organic? So please. It's okay, it's okay. It's okay. You are not the only one. Other people that they are watching your home. So we can continue to extend. Now, the thing is that number one, I'm bothered about your safety. Number one, I'm bothered about your safety. It does not cost me. We can go overnight. But I'm bothered about your safety. That's number one. Number two, your parents, they will not understand that what I'm doing is I'm helping you if anything happens. Your parents won't do it. That is I'm helping you. I've been standing since morning now on my back, on my muscles and everything. Your parents will do it. But if anything happens tomorrow, you will see what your parents can do. And nobody cares. So, but the thing is that if we do not have it tomorrow evening or Monday, then maybe I can't have time again. So maybe next Saturday. So wait. So if I look at it and there is safety, and all of you will not misbehave.
We don't misbehave.
Or someone will not
We don't misbehave.
If you know you will not misbehave, and your parents consent to it, we will see what to do. But if I look at it and it does not look safe, that means we can cancel the class. We might not have on Sunday and we might not have on Monday. So you go and continue reading. See you anytime. I just want us to also sacrifice the money. I'm also supposed to go and be praying and studying. So, all of you prefer the overnight class? Yes, I know. But let's see if that's going to be possible. I've concluded it to be overnight, but let me go and think about it again for your safety. So stay online to know if you have finalized. Oh yeah. So what did I say about sulfur? Preparation is by fresh process. Know about it. Let's keep quiet now, please. Number 2 is the allotropes. They said we have aerobic sulfur, monoclinic sulfur, and amorphous sulfur. Now you need to know the difference between monoclinic and aerobic. It's a common. It's okay, please. Hey, it's okay. You need to know the difference between monoclinic and aerobic sulfur. The shape and the color. Which one is needle shape? Monoclinic is needle shape. So, what is the color of monoclinic? Amber. The other one is? Bright yellow. So, note those differences. They can ask you. Then, notes or read about it. The effects of temperature on sulfur. Effects of temperature on sulfur, it is in your Bible. It's just like a part of the page. Effects of temperature. As you are continuing to increase temperature, sulfur continues to change its shape. And you need to know the shape at a particular temperature. But one of the common questions in JAMB is that at 200 degrees Celsius, sulfur will have its maximum viscosity. It will be viscous, highly viscous at 200 degrees Celsius. So sulfur will be highly viscous, thick at 200 degrees Celsius. So they can ask you, sulfur has its highest viscosity at what temperature? Or at 200 degrees Celsius, what is the property of sulfur? So it has the highest viscosity, highest thickness at 200 degrees Celsius. There's a part that it forms a flower pattern. Please note all those statements on the temperature and this. I would have loved that you would off this and run it again so that you speak better. So you can off the mic, off the speaker and run it again.
Bluetooth mode.
So for the, what's it called? You see now? It's clear now. I just discovered that. Now, for the so don't forget effects of temperature on sulfur. So it will keep changing as you are adding heat to it until it reaches its maximum viscosity at 200 degrees Celsius. Then another thing you should not forget, sulfur burns with blue flame. When it is burning in oxygen, it burns with blue flame. You need to note the uses of sulfur. Sulfur is used in making matches, ishano, explosives, and all of those things. So please note the uses of sulfur. And one aspect Imosuelo are very important that you should note. Is that taken? Now, you can have hydrogen sulfide. You can have SO2. Please, let's note something about SO2. The SO2 bleaching action. I told you that SO2 can act as both reducing and as oxidizing agent. Abi? Yes. Now, SO2 has a bleaching effect. So let me show you how SO2 bleaches. So SO2 can remove the colors of materials, like the hats, the straw hats. How many of you know straw hats? That brown hat, Abby? So SO2 bleaches, it removes color. Now, what it does is that bleaching action of SO2. So the first thing SO2, every time you want to carry out bleaching action, water is always needed. So SO2 will first one react with water to form A2SO3. Then whatever material you want to recolorize, so whatever the dye that the material has, the dye will have oxygen with it. When oxygen is present, then it will be colored. It will have a particular color. So what SO2 will do is to remove the oxygen, then it bleaches it. So the A2SO3 produced here will react with that dye. Then it will remove the oxygen. Then you will now have dye plus A2SO4. This dye without oxygen is now colorless. So it has bleached the dye. It has removed the color from the dye now. So it's becoming colorless. That's what we call the bleaching action. Is that, how does it bleaches? Is it by reduction or by oxidation? Reduction. What did it do? It removed oxygen from dye, Abby. So it bleaches by reduction. So the dye will undergo reduction. That is the one undergoing reduction, which means that this guy SO2 will be acting as a reducing agent. So it bleaches dye by what? Reduction. It's a common question they can ask you. Are you there? So now, another thing is contact process that you need to remember. SO2 is used in contact process. Contact process is the process of producing A2SO4. The first step of contact process is that you react sulfur. You react SO2 with O2. Then you produce H2. You produce SO3. Normally, you could have dissolved the SO3 in, you can start from here, sulfur plus oxygen to give SO2. Then the SO2 reacts with more oxygen to give SO3. Then, if you dissolve the SO3 in water, you could have gotten this, but you don't do that because, yes, so it is exothermic too. So you take the SO3, you react it with A2SO4 first. And this will give you oleum. H2S2O7. This product is called oleum. Oleum. So how do you now get A2SO4 back? So the last step, you take your oleum. You now dissolve it in water. So this will now give us A2SO4. That A2SO4 is called oil of vitriol. So that is called oil of vitriol. So this process is called contact process. And what is the catalyst we use during this process? Or platinized asbestos. Is that taking? So that's what you have. But you remember when we were solving it on the action question, we said that they don't use this again, because it is carcinogenic. So that's the contact process, the process of producing A2SO4, which is known as oil of vitriol. Are you there?
Yes, sir.
Don't forget that whenever SO2 bleaches die, that thing that is bleached after being exposed for a while can regain its color. Why? Because you know it can, if oxygen returns, then you can get your color back. So the color of those straws and all can be restored. So you can just read that part about it tonight. Are you there? So those are the things you need to make by SO2. So what else? So don't forget the uses of sulfur, and don't forget those temperature effects on sulfur. Then let's move on to group 7 quickly. There's A2SO. Then don't forget A2S. In case you don't talk about what's it called? We are still supposed to talk about qualitative analysis. For what's it called? A2S. Anytime you hear a rotten egg smell, that is A2S. Is that taken? Rotten egg smell. There are some other reactions, A2S, like it will give a black precipitate when you react it to its lead acetate or lead nitrate. So it will give a black deposit of lead sulfide. Are you following what you are saying? So the next one, group 7, and the group 6. Wait, oxygen come. So let's talk a bit about oxygen. Let's quickly talk about one or two things about oxygen. The one thing that is important about oxygen is the preparation of oxygen. Are you there? A2S. Well, A2S will be the deposit of sulfur, but SO2 will not. It's part of the qualitative analysis. Now, please, let's note this. Do you have the reaction? Can you give me the reaction? SO2 and A2S, note this. Just note this. When SO2 reacts with any oxidizing agent, maybe K2Cr2O7, is going to be acting as reducing agent. In this case now, it will give several products, but there will be no sulfur, no deposit of sulfur. That's the difference between this guy and this guy. So if A2S is the one reacting with K2Cr2O7 or any oxidizing agents, when all the products are produced, sulfur will be deposited alongside. That's what you need to know. There will be a yellow deposit of sulfur. So when you react SO2 with oxidizing agents, there will be no yellow deposit of sulfur. But when you react A2S with oxidizing agents, there will be a yellow deposit of sulfur. It's a common question in qualitative analysis. So if we had done that, I would have listed some of these things too. So that's that. For oxygen, you all know how you produce oxygen. How do you produce oxygen? The composition of KClO3, and the decomposition of A2O2 using MnO2 as catalyst. Go and watch that part where I said, how do you collect oxygen? How do you dry oxygen? Some of these things you use A2SO4 to dry the oxygen gas. When you collect it over mercury, very good. So Note all those things. Then for oxygen, when oxygen reacts with metal, we have different types of oxides. One, basic oxide. Abi? You know the examples of basic oxide? That's when you react a metal with oxygen. You usually have what we call basic oxide. When you react non-metal with oxygen, you have what we call acidic oxide or acid anhydride. Is that taken? When you react some metals with oxygen, metals like aluminium, zinc, lead, zinc, you have what we call amphoteric oxide. Abi? Amphoteric oxide. Then you have neutral oxide when you react some gases. NO, CO, H2O, they are called what? Neutral oxide. Is that taken? So note all of those for oxygen, that's all. Now, for the halogens, chlorine and its compound. Halogens, so let's quickly talk about group 7. Oftentimes you see questions on chlorine. Number one question you might see on chlorine is the preparation. How do you prepare chlorine? That's number one. You usually prepare it when you mix HCl with KMNO4 or all these oxidizing agents. Then you can produce chlorine. The second thing is, how do you collect chlorine after production? It is collected by downward delivery, upward displacement. Is that taken? That's number 2. The next thing you need to know after that are the properties of chlorine. What is the color of chlorine? It is greenish yellow. Are you there? Another thing you need to know about chlorine is that they can tell you that HCl is produced alongside. How do you remove the HCl when you are producing chlorine? It's in that video. By dissolving in water. Abi? Now, don't forget, when you want to produce H2S, you use what you call a fumes compound, or you use a Gibbs apparatus. Gibbs apparatus. So can we move on? Can we move on? I hope you are writing these things I'm saying.
Yes.
We are summarizing it. Then chlorine, just like sulfur, the bleaching action of sulfur. Let's talk about the bleaching action of chlorine. Then I'll talk about chlorine as a bleaching agent. Or what's that one? So let's look at the bleaching action of chlorine. I'm using chlorine to represent every other members. Most of your questions are always on chlorine. Now, bleaching action of chlorine. Is that okay? So let's see the bleaching action of chlorine. The first thing, just like sulfur, chlorine also needs water. So when you react chlorine with water, you form HOCl. That's why if you use a water that contains chlorine and you need to wash your clothes and you did not rinse it very well, when you later expose this guy to air, you will produce acid and oxygen. When chlorine water is exposed to air, is that taken? So they can ask you this. Now let's move on from here. This is number 1. Number 2, when HOCl is produced, then you react it with the dye. But the difference between this and this is that this type of dye does not need oxygen. If oxygen is present, it will not be colored. So when there is no oxygen, it will be colored. That's the difference. That's why the answers are different when they ask you in exam. So, what does chlorine do now? It will add oxygen to the dye. And when oxygen is added to the dye, it becomes colorless. I hope you are following. So chlorine bleaches by adding oxygen to the dye. Meaning that the oxygen will undergo what? Oxidation. So you say, the dye will undergo oxidation. That means that chlorine bleaches by what? Oxidation. SO2 bleaches by what? Reduction. Do you get that?
Yeah.
And this, that means that chlorine is going to be acting as the oxidizing agent. So, then you have your byproducts. Don't forget this one. It's one of the reasons they would not say you have to rinse your clothes very well. So let's talk about bleaching powder. How do you produce bleaching powder? So they can ask you for the formula for bleaching powder. When you react CaOH plus chlorine in the presence of water, you form CaO.H2O. So this formula is called bleaching powder. So they can ask you for bleaching powder. Is that taken? When you expose this bleaching powder to air, it will liberate a gas. I think they ask you that in all. So when you expose this, it will liberate CaOH plus Cl2 back. When you expose to sunlight. So please, these are the things you need to know about chlorine. Bleaching action and bleaching powder. So this is called bleaching powder. Are you there? It's cool. This one would have added. So there is no water here, please. Can we move on? Are you there? So now that we know about chlorine, there's a reaction that is common to halogens. Halogens always displace each other in reactions. The ones above, like fluorine, chlorine, bromine, iodine, the ones above used to displace the one below. So if I give you a reaction like this, and I say that which one is possible? So you tell me the one that is possible here. So if you look at these reactions, which one is not possible? You know, in exam, sometimes they will not write it in full for you. What they have just done here is to say that chlorine plus potassium iodide, she gets. So they are now removing the positive part and only showing this. But many people used to get confused with that. But it's easier here because you know that chlorine is displacing iodine. Then this will now form KCl plus I2. That's what happened. But instead of showing you potassium, I removed it. Do you get that? So is one possible? Yes. Because chlorine can displace iodine. Abi? Is two possible? No. Iodine cannot displace chlorine. Is three possible? Yes. Chlorine can displace iodine. Is that taking? Is that taking? Now there's a general reaction you need to take notes here. This is a reaction for all of them. Halogens, common reaction of halogens. The common reactions of halogens is that chlorine, I'm using chlorine as an example now. You react it with sodium hydroxide. Now, any one of them can undergo this reaction. There are a lot of questions. They ask this question a lot of times. When you react chlorine, if this guy is cold and dilutes, then you are going to have NaO plus HCl where? Plus A2 plus NaCl. So the question they ask you here is this. When you react chlorine or any of the halogens with a base, sodium hydroxide in particular, and it is under, this base is cold and dilute, your product will be sodium oxychlorate 1. That's your product. So your answer will be sodium oxychlorate 1. But when it is hot and concentrated, you need to also know the products. Cl2 plus sodium hydroxide, hot and concentrated. This will give you NaCl3. This would have also been written an NaCl4. She get. So this is it plus NaCl plus H2. So this is sodium trioxochlorate 5. Please note that difference. It's one important reaction for the halogens. Are you there? Yes. So when they react with base, they form this or this, depending on the conditions. So what other thing have I not talked about? God is trying. So, for the, I remember something, HCl. So don't forget your fountain experiments. Do you still remember fountain experiments? Yes. Yes. So read about the two gases used for fountain experiments are what gas? Ammonia and HCl. The HCl will change the color from what? From blue to red. Abi, why ammonia will change it from red to blue? I've explained that. So, another thing we need to note are the uses of this guy, and that's what there's nothing much here. All the things you need to make about group 7 are what I've talked about. So, I guess that's enough for metals and non-metals so far. So if you can go through all those things, practice them, then do those assignments I give you. You are good to go. Are we okay? Eh? So this is 5:28. So we'll take 30 minutes break. Then we'll come back for organic chemistry. Okay, can we use the remaining 30 minutes to talk about acids and salts? Just some important parts. So we can stop at 6. Are you tired? Should I continue? Let's solve questions. Oh yeah, where's the first question? Let's solve questions on metals and non-metals. So open to the page of metals and non-metals. So any question you see that you don't know, then you can refer to about you. You see the answer here. Is that taken? That's how you can do that part now. You don't need to go and read stories. Just use what I've taught you. Then any question where you are solving you don't know, look at that topic, then go back to Ababio and solve it. If there's still time for me, we can complete the rest of the chemistry. If there's still time, or my people can complete it again, just to go through the rest of it. Then you go and solve all of the questions. So for now, with the things you know before, with what we have done so far today, please, you should be able to bring your chemistry up. There are still some parts left, but we should bring it up. It's because some of you are staying very far, and I should not delay you. But we could have done organic chemistry. Organic chemistry is not much. So can you go and solve? You can solve the first question. Zinc sulfide is a type of which oxide? Do you want to solve questions or not? Oh yeah, open your first question. So the hydrogen, carbon, phosphorus, blah blah blah. Oh yeah. If you are using limits, open your past question to page 59. Page 59, oh yeah. Please. Even if it's 10 questions, let me start it with you. Are you there? Yes, sir. So number 1, zinc oxide is a what? Amphoteric oxide. Is that taken? Number 2, which of the following metal cannot replace iron from water or steam? You remember when I started? That was where I started from. There are some steam, some water, some except copper. Are you there? Number 3, this is a general question that you would have done even when you did water. Listen, when carbon dioxide is bubbled into lime water, a white precipitate is formed. If the passage of the gas is continued, the precipitate disappears. The reason for this is what? Now, let me quickly show you that in a single step. It's a common thing that we all know, but just to describe it. Please, what's the formula for gypsum? CaSO4.2. That is, please note that they can ask you. That's gypsum. Then they can ask you the formula for POP. CaSO4. Be talking. These are your questions I'm giving you. So when you pass CO2, through this, you are going to form CaCO3 plus A2O. Abi? So now, this guy is insoluble, right? And you say you have a white, what do you call it? White precipitate, Abi. So that white precipitate is this guy. It is insoluble. Then when you now add more CO2, CO2 is still present. You will notice something. You will notice something. You are going to form CaH, CO3, 2. This one is water soluble. So this one is that white, what do you call it? The white precipitates, Abi. But they now said the precipitates disappeared. So why did it disappear? Because this guy has now been dissolved, Abi. So what's the options? So option A says that calcium carbonate is formed which gradually dissolves. Is that correct? B, calcium hydrogen carbonate is precipitate and then dissolved. D, C, calcium carbonate is formed which on reaction with further CO2 forms soluble calcium hydrogen carbonate. Yes. So you can see that all the options are looking like they are correct. So if you are not careful, but C is the one that is most correct. And then the day you go for composting check. Continue. We are solving questions, we are talking. All of you are talking. You now come and be crying when you see results. Continue. Instead of you to be crying now and be facing it in thoughts, yes. So, I don't even know. What's our handle? What are our social media handle? Shall follow at Primax Privacy. Follow on YouTube. On YouTube. Subscribe. Open it and subscribe. It doesn't bite. And you are not going to pay. Just click on subscribe. For a lot of you, no matter how you get benefits, you are just enemies of progress. You are just the enemies of progress. What will cost all of you in this place that we will post a video and all of you will comment? What will it cost you? What will cost all of you to like? That's why YouTube is not actually, all these pages are not pages that you beg people to do for you. So please don't watch it online and subscribe, like and comment. One of the videos that should be up to like 10,000 views. And you keep on to 15,000. So if you don't subscribe, God will raise subscribe. Sing God. So, follow Then follow at Primax Foundation. Also on all of the social media.
Bluetooth mode.
So the next question, please. Have we solved number 3? What's number 4? Please, those of you that are here to join foundation, please, you can join. Those people that have been paying now, some people drop 500 and they say next week they will get another one now. Little by little, support the community, support the growth. At the end of the month, we do the calculations. Who knows this one? Why am I blushing? We love you, Sodio. You are the best teacher ever. You will eat the fruit of your labor. God bless you. Let me put it. I don't know if I'm the best teacher, but last time. But thank you for observing. And those of you that bought the Fiber Life and drinks and all, God bless you. I'm just joking. Either you bought or you did not buy. God bless you. So we are just trying our best, please. I don't know anything. I'm even praying to God to help me. I don't know anything. I'm just trying my best. You people are my teachers. But when I'm out of my don't come because you call me something, basically your right is right. Which of the following contains true amphoteric oxides? You should know that one now. Oh yeah, look at number 5. I told you about it. When ammonium, potassium and calcium carbonates are heated, what do you have? Wallahi, as a class. E and D. So E is the answer. Number 6. Which of these compounds will not give an oxygen gas on heating? Zinc nitrate will give it, sodium nitrate will give it, ammonium nitrate will give it, hydrogen peroxide. Will ammonium nitrate give it? No, it will not. Is that taking? And you know I wrote ammonium nitrate 5. What will it give us? N2O and A2O. So the answer is E. Almost global for 30, so they did not unveil. Number 6. Number 7. When the bottle of Coca-Cola is open, what is the gas that is involved? CO2. When the glowing spirit is intasted in the mouth of the animal, gives a white precipitate on turning into barium dihydroxide. The gas is what? There's no hydrogen, no. Listen. They said you introduce the gas into a glowing split, then it extinguished it. When you now introduce that gas into barium hydroxide, it gave a white precipitate. That is CO2. Is that taken? That is CO2, please. CO2 does not support combustion. Don't listen. So it does not support combustion. So the answer will be what? CO2. Don't forget that. If you did not see pop sound, you should be careful. Pop sound focuses more on what? Hydrogen. Are you there? Listen to number 9. I think I told you this one too, Abi. In the preparation of carbon monoxide, in the preparation of carbon monoxide by heating ethane dioic acid, The concave sulfates as what? They are activating agents. Well, let's see. Number 10, an amphoteric oxide design. You should know that. Which of the following gases will not further react to oxygen and temperature? So which of them? That's the C, because they have already formed their higher oxide. Number 12. Liquid X reacts with sodium thiocarbonate 4 to give a gas which does calcium chloride solution in the X is what? An acid. That should be under acid base and salt. So you can go and solve the rest on your own. God will help you. God will see you. And thank you so much for your time. You only spent 10 hours. So, but let's see if tomorrow is possible or not. So depends. If you are meeting tomorrow to another thing, it is for physics. So we do everything in physics. That's it. I will let you know the group. God bless you.
Yeah, shut up.